Alright, what we're going to work with now is section 3.8, which is a algebra review basically, the slopes of parallel and perpendicular lines. So if you were fantastic at algebra, here's your trip down memory lane for you. So first thing, let's go over what is slope. And slope is the vertical change. It's a ratio for your line that compares like your vertical change to your horizontal change. So it's the vertical change, which we call our rise, compared to our horizontal change, which we call our run. So if you remember, it's rise over run. Or the way you could find your vertical change was your y2 minus y1. Your horizontal change you could have found from x2 minus x1. Alright, so that was slope. Now, go back and remember your equations of lines. Slope-intercept form is y equals mx plus b. M is the slope and b was your y-intercept. Alright, so there's a good picture to remember all of that. Now, the one that we're going to want to use more than anything is called point slope form, and it's the one that everybody forgets. So, let's go back over point slope form. It's y minus y1 equals m, and then parentheses x minus x1. Again, m is your slope, y1 is your y coordinate, and x1 is your x coordinate. And this is the one we want to be using a lot. Once you get in higher level math, this one kind of drops off the face of the earth. So we're not going to be focusing on slope-intercept form too much. We're going to definitely be using point slope. Now, this whole chapter has been about parallel and perpendicular lines, so let's talk about the slopes of those. If two non-vertical lines are parallel, then their slopes are equal. So that's something from Algebra 1. If you're parallel, then your slopes are equal. If the slopes of two distinct non-vertical lines are equal, then those lines are parallel. Well, we have to make a difference for vertical lines because vertical lines, if you remember, what's the slope of a vertical line? It's undefined. And you can't say undefined equals undefined. So we make a special case for vertical lines. And any two vertical lines or any two horizontal lines are parallel. Alright? Now, going back to perpendicular lines. If two non-vertical lines are perpendicular, then the product of their slopes is -1. And you probably remember that as opposite reciprocals, which means like if I had, let's go with 3/5, its opposite reciprocal was -5/3. If I do my product, if I multiply these, I get -15 over 15, which is -1. If the slopes of two lines have a product of -1, then the lines are perpendicular. So that's just our converse. And any horizontal line and vertical line are perpendicular. So let's work with all of these things and decide, all right, first question, are lines 1 and line 2 parallel? And we have to be able to explain this. So in order to explain if they're parallel, we need to know their slopes. Okay, so I need to know my rise and my run. So from here, I'm going to run, and so from here, I'm going to rise. So let's count my rise. 1, 2, 3, 4, 5, 6, 7. Okay, so for line 2, my slope, we rise 7, and we run 1, 2, and to the left, so that is -2. Now, let's do line 1. So, my rise, well, that was actually my run. Haha. And now there's my rise. So, I'm rising 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. I'm rising 9 blocks and I'm running 1, 2, 3. And again, to the left is negative, and this one reduces to -3. So my question is, are these lines parallel? Well, in order for them to be parallel, they have the same slope. So no, these are not parallel, and explain they have different slopes. Awesome. Now, what if you're not given a graph? Can you find slope without a graph? So line 3 contains the point A, which is negative 13.6, and the point B, which is negative 1.2. And line 4 contains the point C, which is 3.6, and the point D, which is 6.7. And I want to know, are these parallel? So I'm going to look at line 3 first, and I need to find my slope. I have the option of doing y2 minus y1 over x2 minus x1. Now, it does not matter which point is 2 and which point is 1, just keep them the same. I'm going to make that point 2, that point 1. So my y2 is 2 minus my y1 is negative 13. My x2 is negative 1 minus, I definitely put the wrong number there, minus 6. My bad. And then my x coordinate is my negative 13. So 2 minus 6 is negative 4. And then this really means we're going to add negative 1 plus 13 is 12. So this reduces to negative 1/3. Now, a lot of people make mistakes with slope, just like I did. Alright, so I don't like the slope formula. I try to think and just process and try and think of my slope. And my slope is my rise over my run. So, if I'm going from 2 to 6, what did I rise? Alright, I had to go up 4 to go from 2 to 6. Now I'm going to run. I'm going to go from negative 1 to negative 13. How far do you have to run to go from negative 1 to negative 13? We have to run a negative 12. So that's going to give me a negative 1/3. So I like this approach better. Just think of your rise and your run. So let's look at slope 4. Okay? Our slope here is let's go from our rise. So from 7 to 6, I have to rise 1. Now, my run from 6 to 6 to 3 means I have to run negative 3. So are these lines parallel? They are parallel because they have the same slope. So yes, and to explain, they have the same slope. Okay? Now, let's see if we can do equations with slope, with parallel lines. So what is an equation of the line parallel to y equals negative x minus 7, and it contains the point negative 5,3. So in order to be parallel, I know I need the same slope. So my slope here is negative 1. And I'm going to be using this point, which means I need point slope form. So point slope form was y minus y1 equals m parentheses x minus x1. So now I'm going to substitute in my coordinate and my slope. So it's going to be y minus 3 equals, our slope is negative 1, and then x minus a negative 5. Now, I don't want to leave this, so I'm going to rewrite this as y minus 3 equals negative 1, and then make this x plus 5. So there is my parallel line, has a slope of negative 1, and it contains the point negative 5,3. Now, let's look at perpendicular lines and see if we can figure out if these are perpendicular. So I need to figure out my slopes of each. So my slope for line 1 means, let's see, how many do I rise? How many do I run? Alright, so 1, 2, 3, 4, 5, 6 rise. And then we got 1, 2, 3, 4 to the left. That's negative 4. So reduce this, we got negative 3/2. Now let's look at line 2 slope. Alright, I'm going to erase all this so it's out of my way. Line 2 slope is going to rise, and then it is going to run. So let's count these. All right, we've got 1, 2, 3, 4, 5, 6. We're going to rise 6, and let's count our run. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. All right, now let's reduce this. 6 over 9, both reduced by 3, gives me 2/3. And now my question is, are these perpendicular? Well, in order to be perpendicular, the slopes have to be opposite reciprocals. And they are. So yes, the slopes are opposite reciprocals. Okay? Now, let's look at this one, and can we do our slopes from our points again? So let's do our slope for line 3. And again, I'm not going to use a slope formula. I'm just going to think, how far did I rise? How far did I run? So if I have the point -1 to 7, -1 to 7 means I had to rise 8. And then my run, 3 to 2. If I'm running from 3 to 2, that's -1. So I know my slope here is going to be -8. Now, let's do slope of line 4. My slope here, my rise, I'm going from 7 to 6. So from 7 to 6 is down 1, so that's -1. And I want to go from 8 to -2. So if I'm at 8 and I have to get all the way to -2, that's -10. So my slope here is 1 over 10. So my question is, are these perpendicular? Well, no. So explain the slopes are not opposite reciprocals. Okay? Alright, now let's do an equation to make sure we've got perpendicular slopes and we've got point slope down pat. So if I want the equation of the line perpendicular to y equals 1/5 of x plus 2 and contains the point 15, -4. Well, the information I need is this slope right here. Okay? The slope here is 1/5. But I need the slope that is perpendicular. So the slope that is perpendicular to that is its opposite reciprocal. My slope I need is -5. And again, I need point slope, which is y minus y1 equals m parentheses x minus x1. So now I'm just going to substitute in y, and this is minus a -4, so I'm going to go ahead and make this +4. My slope that I need to be perpendicular is -5, and then x minus 15. Now this is the equation that is perpendicular. Alright, last one. Same thing. That's perpendicular to y equals -3x and contains the point -3,7. So my slope from this line is -3. So my perpendicular slope is its opposite reciprocal, which should be 1/3. So my equation is going to be y minus 7 equals 1/3 and then x plus 3. And now I have my perpendicular line.